Today we're going to look at section 8.8, which is factoring by grouping. So in order to factor by grouping, it's going to be very important that we know how to find a GCF. So let's review finding the GCF of this. 8x squared y and 18xy to the third. So both of these terms have numbers. To be a greatest common factor means we need the greatest or the biggest number that they both have in common. So when I'm looking at these two numbers, 8 is the smaller of the two. If I can multiply 8 times something to get 18, then I know that 8 is going to be the first number that they have in common. Unfortunately, 8 times something can't get me 18. So that means I'm going to start breaking it up. So what's the next set of numbers that multiply to get me 8? Well, 4 times 2. So then my question is, well, can I multiply either 4 times something to get 18? Because if I can, that's going to be the next biggest number that they have in common. Well, I can't multiply 4 times something to get 18, but I can multiply 2 by something. 2 times 9 is 18. So it looks like the first number that they both have in common, the biggest number is 2. When I start looking at my variables, remember, if it's x squared y, that means I've got 2 x's and a y. If I have an x and then a y to the third, that means I have an x and then 3 y's. So how many x's do they have in common? Well, it looks like they just have 1 in common. How many y's do they have in common? Well, it looks like they just have 1. So remember, when you're looking at the variables, you have to take the smaller of the two exponents. So my greatest common factor would be a 2, an x, and a y. All right, so now that we've reviewed finding the GCF, let's review factoring it out. So if I have 5ab minus 20a squared bc, I want to first find the GCF, but then to factor means that I put whatever's left over back in parentheses. So let's start with the numbers. 5 is the smaller number out of 5 and 20. Can I multiply 5 times something to get 20? And my answer is yes. 5 times 4. So that means that both of these have a 5 in common. That's going to be a part of my GCF. If I start looking at the variables, I see that I've got an A and a B. Over here, I've got A, B, and C. So it looks like they both have one A in common, but no more than that one A. It looks like they both have a B in common, but then there's no other variables that they share. So it looks like 5AB is that GCF. So I get to write that, 5AB, but then remember, to factor means that now I have to put whatever's left over back in the parentheses. There were 2 terms that we started with. There's a subtraction sign in between them. That means I should have 2 things left over in parentheses with a subtraction sign in between them. Because everything from that first term ended up being my GCF, I'm going to put just the number 1 inside. Because remember, my GCF, if I was to distribute it back, it should get me what I originally started with. So what am I left with in the second term? Well, we didn't do anything with that 4. We haven't done anything with this second A, and we haven't done anything with that C. So it looks like 4AC is going to finish that out. And this would be my factored answer. All right, so what we're going to be looking at today is we're going to find the GCF. We're going to find the GCF of the first 2 terms, and then we're going to find the GCF of the last 2 terms, because notice in these problems, there are actually 4 terms. So in this first one, we've got 3x squared plus 21x plus 10x squared plus 70x. So what we're going to do is we are going to group the first 2 terms by putting parentheses around them. I'm then going to group the next 2 terms by putting parentheses around them. I know that I grouped correctly if there is an addition sign in between those 2 parentheses. And I have an addition sign, so I know that I'm good. So that's why we practice finding the GCF. I want to focus just on the first parenthesis with the 3x squared plus 21x, and I need to take out the GCF, factor it out. So notice that 3 is smaller than 21, and I can multiply 3 times something to get 21. So it looks like 3 will be a part of my GCF. If I look, both of these have a variable. If the first one has x squared and the second one is just an x, remember I have to take the smaller of the two exponents. So x technically to the first is smaller than x squared. So that means I only want one x taken out. So now I'm going to put whatever's left over back in parentheses. I want an addition sign breaking them up because there was an addition sign in my parentheses. So notice that with the first term, I took out that 3 and I took out one of the x's. It's going to leave me just with an x. In the second parenthesis, I took out the 3. That left me with a 7. And I also took out the x, so there's no more variable. All right, now I'm going to move on. I'm going to bring down that addition sign from the outside, and now I'm going to focus on the next two terms in the second parenthesis. Because 10 is smaller than 70, can I multiply 10 times something to get 70? And my answer is yes, 10 times 7. So I know that they both have a 10, so 10 is going to be a part of my GCF. Notice that they both have variables. So once again, I need to take the smaller of the two exponents, x squared versus x to the first. I want to just take x to the first. So then that means I have to put whatever's left over back in parentheses. Notice how there is an addition sign breaking them up. I took out the 10 and an x in the first term. That leaves me with an x. In the second term, I took out the 10. That leaves me with a 7. And I took out the x, which leaves me with no more x's. So when it says find the GCF of the first two terms and the GCF of the last two terms, we did that. And this would then be my answer for right now. Notice how we have x plus 7 in the two parentheses. That's not a coincidence. We should, with these problems right now, get the same thing left over in parentheses. If we don't, then we probably made a mistake. But for right now, this is all I want us to do. This would be our answer. Okay, if we take a look at the next example, 6x to the third minus 2x squared plus 9xy minus 3y. So once again, I'm going to group the first two. I'm going to group the last two. I need that addition sign in between. So I'm going to start looking at the first two terms and ask myself, what do they have in common? So between a 6 and a 2, 2 is smaller. I need to ask myself, can I multiply 2 times something to get 6? And the answer is yes. So that means they both have a 2 in common. That's going to be a GCF. They both have variables. Between an x to the third and an x squared, we take the smaller of the two exponents. So that means x squared is what they have in common. So then I have to put whatever's left over back in parentheses. With those two terms, notice that there is a subtraction sign breaking them up. So with the 6x to the third, I took out the 2. That leaves me with a 3. X to the third have 3 x's, but outside I only have 2. So that means there's still an x. On the inside of the second term, 2 got taken out and x squared got taken out, so that leaves me with just a 1. I'm going to bring down that addition sign, and now I'm going to do the same idea with the next parenthesis. Between the 9xy and the 3y, let's start with the numbers. 3 is smaller than 9. I can multiply 3 times 3 to get 9, so they both have a 3 in common. If I look at the variables, they both have a y in common. So what does that leave me with? Well, notice that there are two terms in parentheses. There is a subtraction sign that needs to break them up. So 9 was 3 times 3. We took out a 3. We're still left with a 3. And notice that with the variables, we took out a y. That still leaves me with an x. In the second term, that whole entire 3y got taken out, so that leaves me with a 1. Notice how we did this correctly because both of the parentheses left me with 3x minus 1. So this is my answer. Two more problems. If I have 4a squared b plus 2a minus 22ab to the third minus 11b squared. I'm going to group the first two terms, and I want to group the second two. But notice that what I see is not an addition sign. I see a subtraction sign. So I actually need to group the negative with that 22, and I have to put my own addition sign in between those parentheses. Okay, so I need a parenthesis breaking up I need a plus sign breaking up the parentheses. Let's start with the first two terms. I see 4 and I see a 2. Well, 2 is smaller, 4 is 2 times 2. They definitely have a 2 in common. Then I see that they both have some a's. Remember, I take the smaller exponent, so that would be a 1 versus the a squared. Even though that first term has a b, I don't have a b in the second term, so there's not going to be a b in my GCF. So I should have two things left over in parentheses with an addition sign breaking them up. Since 4 was 2 times 2 and we took out a 2, we're left with a 2. Since a squared, only one a got moved out, we still have an a, and we still have that b. If we look at the second term, the whole entire term got moved to the outside, so we're left with a 1. I'm going to bring down that addition sign that I just created, and now I'm going to move on to the second parenthesis. Notice that we have a negative 22ab to the third and a negative 11b squared. So negative 11 is smaller than negative 22. Can I multiply negative 11 times something to get negative 22? And my answer is yes. Negative 11 times 2 is going to get me that. So they both have a negative 11 in common. If I look at the variables, they both have b's, and they have 2 of them in common because I take the smaller of the 2 exponents. So now I need to put what's left over. So looking at the negative 11 times 2 to get me the negative 22, the 2 is going to be left over. We'll still have an a because I didn't move that to the outside. If it was b to the third and I only took out 2 b's, we still have a b. Now, because I took out a negative 11, I have a positive 1. Because remember, I want to be able to distribute and get me back to what I started with. So negative 11 times 1 will get me negative 11. The b squared also moved to the outside. Notice how I want to have the same thing in parentheses, which in this case I do. So that means that this is my answer. Last problem, we've got 9m squared minus 3mn minus 30mn squared plus 10n to the third. So I'm going to group the first two. And once again, I need an addition sign breaking up my parentheses. Right now, I see a subtraction sign. So that subtraction sign has to stay with the 30. Let's focus on the first two parentheses. I see a 9 and a 3. 3 is smaller. 9 is 3 times 3. They have a 3 in common. Looking at the variables between an m squared and an m, I take the smaller exponent, so m. The second term has an n, but the first doesn't, so no GCF with an n there. So what is left over? Well, 3 times 3 gets me 9, and I took out one m, so I'm still left with an m. I'm going to bring down that subtraction sign. The 3 got taken out, the m got taken out. I'm still left with the n. I'm going to bring down that new addition sign that we just created. Now I have negative 30 and positive 10. So I need to figure out what do I need to take out of those two numbers. 10 is smaller than 30. I can multiply 10 times something to get 30. It's 10 times 3. Here's the thing. I need to have my second parenthesis turn into 3m minus n. So that means the 3 has to be positive, which means the 10 has to be negative because I need to multiply to get me negative 30. So if that 10 is negative, that means I need to make this 10 negative as well. But how do I make a 10 negative if it's positive? Well, I have to multiply it by negative 1. So I get to take out a negative 10, and I see that they both have an n in common, and not just one, but I take the smaller exponent, they have 2 n's in common. So what's left over then? Well, that positive 3 and the m for the first term. Notice how the n squared got taken out, so there are no more n's left over. Okay, normally I would put an addition sign. However, notice the number that's left is a -1. So we could write -1, n squared got taken out. I have n to the third. That means that there's still an n. So even though I put a 1 there, I could technically put a 1 over here. Notice how this does give me the same thing left over in parentheses. So then this would be my final answer.